As I mentioned at the beginning of the class, there are many white box criteria, and we're not going to have time to cover them all. So what I like to do now is just to give you the flavor of some other criteria by just mentioning them and saying a couple of things about the way they work. And the first one I want to mention is path coverage. And in path coverage, the test requirements are all the paths in the program. So what that means is that to satisfy this criterion, we need to generate enough test cases such that all the paths in my program are covered. As you can imagine, this is incredibly expensive because any non-trivial program has got a virtually infinite number of paths. And therefore, we will need a virtually infinite number of test cases to satisfy the path coverage criterion. Another family of criteria I want to mention are data flow coverage criteria. And in data flow coverage criteria, the focus shifts from the coverage of individual elements in the code to the coverage of pairs of elements. And in particular, the coverage of statements in which the content of some memory location is modified and statements in which the content of the same memory location is used. So in this way, our test will exercise the assignments of values to the memory and the usage of those assignments. Finally, I want to mention mutation coverage. And this is a fairly different and new idea. So the key concept in mutation coverage is that we want to evaluate the goodness of our tests by modifying the code. Like, for example, here in small, I'm showing that I might change an if statement from k greater than 9 to k greater than or equal to 9. And the reason why I want to do that is that if I generate enough mutants, enough variation of my program, then I can use them to assess how good are my tests at distinguishing the original program and the mutants. And because I'm changing the code based on the way I expect to introduce errors in the code, the more my tests can identify mutants, the better they are at identifying real faults. This is a very high-level view, but just to give you the intuition and the idea behind this criteria. And I'm going to provide, as usual, additional pointers to go in more depth on these topics in the notes of the class. So now let's go back to our test criteria subsumption hierarchy and see how all of these criteria fit together in this context. Let me start with multiple condition coverage. As we saw, MCDC is sort of a smarter way of doing multiple condition coverage in the sense that it doesn't consider all the combinations, but only the ones that are more likely to matter. And as such, MCDC exercises a subset of the elements that multiple condition coverage exercises. And therefore, multiple condition coverage is more thorough than MCDC and subsumes it. And it's also, as we saw, incredibly more expensive. Path coverage subsumes branch coverage because if I cover all of the paths in the code, I necessarily cover all the branches. However, it doesn't subsume multiple condition coverage, MCDC, or branch and condition coverage because these criteria have additional requirements involving the conditions of the predicate that path coverage does not have. As for data flow coverage criteria and mutation coverage criteria, they're really in no relation with the other criteria because they look at different aspects of the code. So they're not really comparable. And therefore, we're just going to put them on the side without any relationship with the other ones. The reason why I want to represent them all anyways is because I want to make an important distinction between these different criteria. And that's the distinction between practical criteria, which are criteria that are actually not too expensive to be used in real scenarios, and theoretical criteria, which are criteria that are useful in theory from the conceptual standpoint, but they're not really applicable in practice because they are too expensive, because they require basically too many test cases to be satisfied.